Hello guys, how are you? How you doing? Today we'll finish our classes about the spherical tanks. Yesterday we did the hemispherical tank. Today I will discuss how we find the work for spherical tanks. Before I start, if you have any question, just text me or send me an email. Don't forget please to like and subscribe. Then today we'll discuss the spherical tank. Okay? Yesterday we did what? The hemispherical tank. That's what we did yesterday. Just go back and review that class for yesterday and you will see that. And don't forget that we have SAT classes running soon in June 25. If you have friends, if you have brothers, sisters, just let them contact us. Okay, let us see the problem first. Yesterday, this is the problem. As I put the equation right away. A spherical tank of radius 10 feet is half full of oil that weighs now weight density, right? 60 pounds per cubic foot. This is the weight density. That will help me a lot, right? Find the work required to pump oil out through a hole in the top of the tank and a circle. This is what I'm going to discuss with you, which is we discussed it yesterday. Okay, let me just go and find the equation on the line. Before always guys, always, before you start doing any problem, see what formula you're going to use. The work equal force for the tank, this tank, from 0 to R, F dy, this is the formula. In my case, the force is the weight of the fluid, the oil in the spherical tank. In the fluids, the weight equal what? Rho V. You see that here? The weight equal what? Rho V. The weight equal, remember this one. Whereas rho is the weight density, right? And the V is the volume of the tank. Before I start doing the problem, I start to analyze my formula. The work is F dy. For the limit, 0 and R, is that changing? Depends on the problem. When we have fluids, the force will be the weight, dy, because we either emptying or pump in or out of this tank. The changing will be, if it's spherical, it's going to be for X and Y, because the radius of the circle, I'm going to show you now, will change. Now, and weight, we said equal rho V here. In this case, the force equal weight. Now, start your problem now. You have to find the volume, and you see which part of the volume changing. Volume equal AY times the height of that fluid you want to pump, if increasing or decreasing. Then the force equal root V AY. Let me find AY. AY is what? Let us see what we have. Let us see the circle. Okay, let me just go to my board. Okay. Minimize this and see. This is my circle. I prepared for you to have what? My sphere. Look, guys. 1, 2, 3, 4, 5, right? It's 10. Radius of 10. Diameter of 10. Or radius, I count by 2. Count by 2. 2, 4, 6, 8. This point here. 0 and what? 10, which is the center of the circle. I took a cross section. You see the green bar? It's a cross section. To know what I mean, I'm going to take this one minimize it and take another one. Okay. The equation of the circle from yesterday, x minus n squared, y minus m squared. We have x and y. At any point here we have what? This, you see this? Here, x and y. X and y. Here we have x and y. Here we have, look here, at this point, this cross section. This x and the y is going to come all the way down, right? At this point, x is more and y is less. You can take any point, you will see this is x, this x, you see? And this y, and y is good, big, right? And this cross section equal r squared. This is the equation you have to remember. Now x, right, minus 0. The center is, what's my center? N and m, which is in my case 0 and 10. X minus 0, 0 square, y minus 10 square, and the radius r square, which is 10, which is 100. Always that gives you the radius, always, all the time, look here. All the time, give you the radius. You see r, you see that? Between x and y, right? It's r, right? It's always, from the point to, because this cross section, from the point to the center, from any point in the circle to the center is r. From any point in the circle to the center is always what? R. Okay. Then I have the equation, which is, I have it here. Here. You see that? This is the cross section. This is the circle. Any point, look here. That's what I mean. If you take here, here. This is because this cross section, vertical cross section. This R, R, and x, y. If you put x and y, here, x and y changing. It depends on which point on the circle. Always we have small cross section. With my mouse here, I can take this one. I'm going to show you something. I'm going to take this circle, copy, paste, give it different color. Let me give it, we have blue, we have this guy. Oh, let me just make it not green, this is green. Yellow, okay. I'm going to take this one, I'm going to show you another cross section. You see, it depends, this could be here. Cross section here, right? You see that? I can just take it a little bit down. Cross section here, and you can have cross section. You see the circle, the amount of fluid here is different. The cross section start to increase. Then, since the radius of the circle, is small circle is x, right here or here, since here, right, it's x. I can solve for x because the height changing, the height of the fluid. You see the fluid here, the height of the fluid changing. I can find x in terms of y, which is area equal area of this circle in terms of y. The area is by x squared. Area is what? Pi r squared. But r here, the radius, is not the actual radius, is x changing, keep changing. X, the value of x in the circle. Like this. I'm going to graph it here one more time. As I said, if we have the vertical circle, we have y, and we have what? X here, right? The radius of the circle is what? X, but X changes, small, the circle, right? Small circles, small circles, small circles, small circles, big and small. Then R the cross section. This R the cross section radius. The cross section radius. The cross section radius, not the actual sphere radius, by x squared. Solving for x squared from the equation of the circle. But x squared, how do you get this formula? Because y squared, we said, if you remember that, x squared plus y minus 10 squared equal 100, r squared, this r squared. Then when you move the plus 1y squared, this guy here, to the other side becomes minus, okay? Then x squared equal 100 minus y minus 10 squared, good job. You have to deal with this guy, y minus 10 squared, from basic algebra, y minus 10 squared. You have to multiply y minus 10 times y minus 10, which is give you y squared minus 20y plus 100. Apply the negative sign. When you apply it, it's going to be negative y squared. This guy, I'm going to write it for you. Let me read this. The ratio. We don't need this. We know what we need. And this guy becomes y squared minus 20y plus 100. But since we have a negative sign here, this becomes negative y squared plus 20y minus 100, right? This is going to be minus 100. I will change it now in the graph. Then what's going to happen? Which one is going to cancel? The minus, you see the minus here? Effect on all the sign. This is going to cancel. 100 minus 100. Okay. Just let me change this one to be minus. Okay, let me save it. Because if anyone wants this solution, if anyone like to have this solution, right guys? Anyone want this solution, I will send it to you. Just send me your email. Okay. This cancel with that. You see the yellow? Then area of y, pi minus y squared. H of y. H of y. Let me just show you y20 minus y. y20 minus y. Okay. Let us back to our graph here. We said the radius is 20, right? Guy 10, right? And the circle has a radius of what? The circle has this 10 here, and here 10. Total is what? From here to here is what? Total 20. The amount of fluid, when you start to pump the gas or the oil, the height will change. The height will change. This is the height y. Every time, every minute, every second. What left from here to here? If all this 20, how much left? 20 minus what? 20 minus y. Because that the height is 20 minus y. Okay. Now the volume, define AY, right? AY is by minus, which is here. AY here, where is it? Here, AY. Just let me highlight it for you after we simplify it. AY and HY is here. Let me highlight. Then we have the volume. AY, HY. AY, HY. AY, HY, which is this one. Now you have to multiply this by this, foil it again. Negative y squared times 20, negative 20y squared, negative y times negative y, 20y cubed, right? 20y, hold on, negative y, negative 20y, negative y times positive y squared, y cubed, positive y cubed. Positive y, negative y times 20, negative 20y squared, right? Negative times negative is positive, y cubed. Now go to this one, 20y times 20y, 400y, minus 20y squared. Good. Now, let me just erase this one. Y cubed, I have y cubed, combine the like term, negative 20y squared, negative 40y squared, plus 400y. I have the volume, I have everything. It's half full, then my limit from 0 to r. I have the formula, that you remember the formula. And rho v dy. Rho is given 50, 60. And here we need to just to cancel this. Let me just sit here and finish it for you. Now look here, I have the work equal rho v, the work equal rho v, right guys, ay dy, then because that 20 is from before, 40y squared, now this is the 20 here, from 0 to the 10. Look what I did. The pi is constant because that area of the circle by r square, it goes out. Now, okay, this is my integration. This y4 over 4. Okay, I don't need this one. And I don't need this one. This is going to be y4 over 4. y4 over 4. Right? And 40y squared becomes 40y cubed over 3. 400y over 2. Integration of 400y is 400y squared over 2. Okay, we list some square over 2. Right? Which is 200y squared. Good. Because 400 power. Now plug what now? This is to the second power. Plug your number from 0 to the 10. 2. And this is, you don't need the 5. Then we have 10 to the 4, 40 10 cubed over 3 plus 200 times 10 watt. And all this becomes 0. Now let us, this one, 10,000. This is 10,000. And this is 4,000 over 3. And this 100 times 200 is 20,000. And all this 0. Then you add this one. This is 10,000 and 20,000 is 30,000. 30,000 minus 4,000 over 3. Multiply this by 3. It's going to be 90,000 because you have to have the same denominator. This is 1. You can do it like this. This is 1. This is 1. Right? Multiply by 3 by 3. This becomes 90,000. It's going to be 50,000. 50,000 over 3. 50 over 3. Multiplied by this. This 3 and 60, 20. 20 times 50. We need, how many zeros we need? 5 zeros. And because 20 times 50 is 100, right? 5, right? This is, right? 90, 50,000. 5 times 6, 30. And we have 40 we need one more, it's going to be 30. Okay, just multiply over 30,000 pi. That my work. I need to find the work required to pump out through the hole into the top of the tank, and my limit was from 0 to 10. Okay, guys, thank you. And if you have any question about this video, you don't have to hesitate, and you just call me. I'm sorry, text me or send me an email. Thank you guys, and have a good day.